Now in this video I'd like to discuss balancing chemical equations. So let's look at a few reactions. Let's suppose we have silver nitrate plus sodium chloride to give silver chloride and sodium nitrate. These are the reactants on this side, and these are the products of the reaction. Now notice that there's one silver on this side and one silver here. There's one chlorine on the reactant side and one chlorine on the product side. There's one sodium on this side, one here. One nitrogen and three oxygens on the reactant side, one nitrogen and three oxygens on the product side. So this reaction is balanced as written. And what this means is that 1 mole, remember in chemistry we use moles when we discuss entities, 1 mole or 6.023 times 10 to the 23rd silver nitrate particles react with 1 mole of sodium chloride to produce 1 mole of silver chloride and 1 mole of sodium nitrate. And so the reaction is balanced. If someone were to ask us how many moles of silver nitrate is required to make 5 moles of silver chloride, we would know that 5 moles are required because there's a 1 coefficient there, there, and there. Okay, let's look at another reaction. Let's try nitrogen plus hydrogen to make ammonia. Now there are 2 hydrogens on this side and 3 on the product side, so this reaction is not balanced as is. So how would we balance this? Well, let's just start trying some things. Let's first of all put a 2 in front of the ammonia. Now we have 2 nitrogens on the product side and 2 on the nitrogens on the reactant side. We have 2 times 3, 6 hydrogens on the product side because we have 2 moles or 2 molecules of ammonia. Each molecule has 3 hydrogens, so 2 molecules would have 6 hydrogens. We have 6 hydrogens there. If we put a 3 here, now we'll have 6 hydrogens on this side. And now that reaction is balanced. Okay, let's try something a little harder. Let's look at a combustion reaction. And remember, combustion reactions involve the reaction of something such as methane with oxygen to produce carbon dioxide and water. Now notice there are several sources for oxygen in this reaction. The easiest way to balance this equation is to balance things such as the carbon atom. There's only one source on each side. And the hydrogen. There's only one source of hydrogen on reactant side and one source on the product side. So there's one carbon here and there's one carbon there. So that's balanced. There are 4 hydrogens on the reactant side and only 2 on the product side. So let's put a 2 in front of the water. And now I think we'll have the carbons and the hydrogens balanced. 1 carbon, 1 carbon, 4 hydrogens, 4 hydrogens. Now let's worry about the oxygen. There's 2 on this side. There's 2 water molecules, each of which has 1 oxygen. There's another 2, so that's 4, and there are 2 here. So you see, if we put a 2 in front of here, then we would have the equation balanced. Now someone might ask us the following question. How much oxygen do I need to generate a certain amount of carbon dioxide? So for example, we could say 44 grams of carbon dioxide. How much oxygen do we need to get 44 grams of carbon dioxide in the product? Well, 44 grams of carbon dioxide is how many moles? There's 1 mole of carbon dioxide It turns out that there are, carbon is 12, 2 oxygens is 32. There's 44 grams of carbon dioxide in 1 mole. So what they've really asked us is how many grams of oxygen are required to make 44 grams or 1 mole of CO2. Well, we know from our balanced equation that 1 mole of CO2 is formed from 2 moles of oxygen gas. Each oxygen weighs 16, so 1 O2 weighs 32, and 2 moles of oxygen must weigh 64 grams per mole. So the answer would be you need 64 grams of oxygen to make 44 grams of carbon dioxide. Let's try another combustion reaction using an organic compound. Let's try this sugar C5H10O5 plus oxygen yields carbon dioxide and water. That's a combustion reaction. So the way we balance that first is let's put a 5 in front of the carbon dioxide to balance the carbons. And next, let's balance the hydrogens. There are 10 hydrogens here, 2 here. So if we put a 5 in front of that, we'll have 10 hydrogens. Now, let's balance the oxygens. There are 5 here. There are 10 in this molecule, so there are 15. There are 15 oxygens on this side. Here are 5. And so to get 10 more, we need to put a 5 in front of that. And so our balanced equation would be C5H10O5 plus 5 oxygens yields 5 carbon dioxides and 5 water. And that's pretty much all there is to it in balancing equations.